Evening, everyone. For those of you who haven't met me before, I'm Catharine Singleton and I'm the Schools Liaison Officer at St Catherine's College in Cambridge. So this event today is part of a series of webinars that St Catherine's Cambridge is hosting with Brasenose Oxford. And this is the first in our academic taster lectures for Year 10 and 11 and equivalent students. So I'm joined today by Dr. David Bainbridge, who is going to be giving this talk.
Hello, everybody. Yes, my name is David Bainbridge. I do various things at the University of Cambridge. But one of the things I do, the main thing I do really, is that I teach on the veterinary medicine course. Now, don't worry if you're not interested in training to be a vet. Not many people are interested in training to be vets. Only a very small number of people who apply for it and do it. This will hopefully be of interest to anybody who's sort of generally interested in the life sciences, really. I teach vets, especially in the early years of their 6-year course, but I'm actually really going to talk about something today which I think really would be covered probably a bit later on in the more sort of clinical, practical end of the course. And it's about a poisoning that I once saw when I was in veterinary practice many years ago. As soon as I graduated, I went into general mixed practice. In Essex, actually, God's own country. Hello to anybody out there who's come from Essex to attend this. I was doing all sorts of animals. I was doing mainly cats and dogs, but I'd see the occasional horse and sheep and cows and even pigs if I couldn't avoid it, and chickens and whatever. Operated on my first fish. And so this is a case that I saw during that time when I was working there in the sunny prairies of Essex. And this was a little dog. I'd seen him a couple of times for other things, nothing very much really. And his owner came in and said that he was very depressed and very aggressive. Now he's, if you're good at dog breeds, you may have realized that he's a Lhasa Apso, which is a little irritating yappy dog, not my sort of dog at all, but anyway, that's what he was, but we can't hold that against him. And she said he'd been very depressed and very aggressive, and he wasn't really eating, and there wasn't really very much coming out the other end either, which is normally something dogs are very good at. I thought, oh, that's a bit vague. It's never really very helpful when people say, oh, he's just a bit off and unhappy, and I don't know really. But she did say he was aggressive. He was more aggressive than usual anyway. She said he wasn't normally an aggressive dog, but he was really he was quite stressed and really just snappy and quite horrible. Not in the way that a normal stressed dog who goes to the vets is. He was just being horrible, really. And I did think that's a bit strange, because that's quite a specific thing. You don't normally see that all of a sudden. I mean, some dogs are snappy and horrible all the time, and that's just the way they are. But to suddenly become it seemed a bit strange. And so I sort of examined him and looked at him, and I couldn't find anything wrong. He had a little row of stitches on his tummy, because actually he'd been in 2 weeks earlier for an operation because he'd eaten something. And it had got stuck in his stomach, and he'd have to have an operation to have it taken out. And that is not uncommon at all. Any of you who have dogs may have had to have this done to your dog, because dogs, A, will eat anything, and B, are pretty stupid. He'd wolfed something down, had to have it taken out, and then so for the first week after that he was fine, but then he just started to get a bit sort of horrible and snitchy and whatever. But he wasn't in pain or anything like that. Nothing obviously had gone wrong with the operation. His stitches were all still there, and everything was fine. And I thought, well, I don't really have much of an idea what this might be, because it didn't really fit into any of the sort of patterns that I would usually recognize in an ill animal. So I thought, well, it could just be a coincidence, obviously, that he had something taken out of his stomach 2 weeks ago. So I looked up on the records, which in those days were written on little cards. We didn't have computers to do it in those days. That's how long ago it was. That's how old I am. And so I flipped through the little white cards, and I saw who'd done the operation on him, and he was working in the room next door. So I went in to see him, interrupted him, and told him what happened. And he said, Yeah, it was weird. The thing I took out, I kept it in a little pot, in a little plastic pot. So we went into the surgical theatre, and there was this little plastic tube, and it had this lump of grey stuff in it, and it didn't look particularly exciting. In fact, it looked like a very small piece of.
Oh, David, you managed to unmute yourself when you clicked.
How did I do that? I don't know.
After
Anyway,
1 year of webinars.
so I haven't been muted for the last 5 minutes, have I?
No, it was just a quick slap.
It was just then. Okay. Anyway, so the what came out of his stomach, not that I was there, so the other guy was doing it, was a little piece of this sort of stuff, sort of grey, flexible, bendy material, and I held it in my hand, and it was heavy, and I thought that's a bit strange. And then between us, I'd like to say it was me, but I think it was between us, we put 2 and 2 together, and we realized what might have happened in this animal, and we realized he'd probably been poisoned by this stuff while it was sitting in his stomach. Now, on the Q&A, type in if you've got any guesses as to what this stuff might be that might cause poisoning. Oh, God. Oh, straight in there. God, they're all stacking up now. Yes, very good. Ooh. Raise them. Yeah.
I'm really impressed because I wouldn't have known.
Yeah, that's very good. I mean, even actually the answers that are wrong, the answers that didn't turn out to be the case are quite sensible. So basically, yes, the answer is it's lead flashing. And somebody said, is it a heavy metal? We'll get onto that because lead is just one of several that could have caused this. This was actually lead, actually. So yeah, well done, everybody. Good to know somebody's out there. And yes, indeed, it is lead flashing, and it's characteristically heavy. I'm sure you know lead; it's very heavy, and also it's lovely and bendy. And the reason people like it, I was actually using it a few weeks ago on my house. I probably should have worn gloves really, but anyway, is that it's called flashing. I don't know why it's called flashing, but basically it's this lovely bendy but very resilient and completely waterproof, obviously, sheet of bendy metal that you can fit around sort of crevices and nooks on your house, and it stops water coming in. And that's why people use it, and you can buy it in big strips. But the problem is if people cut off a bit and drop it, you know, imagine if you're cutting one of these little triangular bits on this bit of roof here. You cut off one of those little triangles. If you just drop it into some plants in the garden, then the dog will find it and go, right, I'll have that, and he'll eat it. And that is a problem. So, as somebody said, they didn't know if this is relevant, but apparently it tasted sweet. I've never tried it, I have to say. I don't know if the metal tastes sweet, but it might be converted into a different chemical in your mouth, which might make it taste sweet. So yeah, unfortunately, quite a lot of things that are poisonous taste rather nice, like antifreeze and things like that. But anyway, so I thought, oh, lead, well, that's kind of brains and guts and things, isn't it? And lead has been linked to behavioural changes, as we've seen, as we'll see in a bit. So I thought, has this dog got lead poisoning from having this lead in his stomach? And I started thinking back to my school chemistry, actually, to be honest with you, rather than anything I learnt at vet school. Lead. Why lead? Why is lead poisonous? What's so special about it? If you can remember the 2-letter symbol for lead that we have in the periodic table, you can type that in now as well. It's either if you're good at chemistry, or it could be if you're good at Latin, I suppose, but I think chemistry is probably more likely. Yeah, very good. It's Pb, because the Latin for lead is plumbum. As in, you don't know, if you've ever seen anybody doing any DIY, sometimes they have, very good, lots of PBs coming up. it's people do a thing called they drop a plumb line. They have a piece of string with something heavy on the end, which traditionally was a piece of lead. It's not anymore, obviously, and that's how you measure verticals. If you're building a house or something like that, use something called a plumb line, and that again comes from the same origin, plumbum in Latin. Somebody's already mentioned lead acetate. We'll come back to lead acetate in a bit, don't worry. Yes, so that's what lead is. My next picture is, I'll try not to mute myself this time, is a periodic table. So here is the periodic table. I don't know how much you've had to do the periodic table yet, probably a bit, I should think. It's a way that there are 92 naturally occurring elements in nature, and we can arrange them according to basically the number of protons in the nucleus. And if you do that, the simplest one is hydrogen, which has 1 proton, and then we have helium on the top right, which has 2 protons, then lithium, beryllium, 3, 4, 5, and then carbon is 6, for example. You go on all the way up. And as I said, there are 92 naturally occurring elements, and in general, they get heavier as you go higher. It's not an absolute correlation, but it's it's pretty good. And as you see, lead is very high up. It's 82. So really, it's the, if you actually look at the ones beyond it, it's the highest one you're ever going to encounter in normal life. Really, lead. So it's the heaviest element that anybody ever sees. I think it's probably safe to say. You're not going to see much francium or bismuth around the place. But then if we look at the other picture I've got here, this is a graph of, so the elements 1 to 92 are along the bottom axis, horizontal axis, the x-axis. So we've got H, hydrogen, right on the left-hand side in the green area. And this is a graph of the abundance of these metals in the Earth's crust. And you can see that in general, the bigger ones are less common. They're lower down, but it's a pretty messy graph, isn't it? It's a very, random correlation. And actually, if you look towards the end of it, lead in red, nearly at the right-hand side, is, well, it's the most abundant of the big elements as well, isn't it? You have to go quite a long way down to somewhere sort of right around barium, I suppose, around here. So considering how heavy and dense this element is and how far down the table it is, it's weirdly common, which is why you see it, and it's why it's actually, you wouldn't put gold strips on your roof. Probably would work, but you wouldn't do it because it's very rare and it's very expensive. And so lead is very large, weirdly large, and weirdly abundant. So what has any of that got to do with this little dog? Well, lead poisoning is sadly quite common. I've read a few times that it's the most common animal poisoning in the world. I'm not sure if that's actually true, but some people claim it is anyway. And it's also not that rare in people as well. Where does it usually come from? Well, as you may know, old-fashioned paint used to have lead in it. Lead makes these lovely milky white salts. Well, I say they're lovely, they're full of lead, so they're toxic, but it means that they used to make paint out of it, because you slap it on the wall and you have this lovely white wall, and it's much better white paint than used to be available in any other format. And so lots of old houses have lead paint in the wall. They actually have lead in the wallpaper paste as well. So one of the most common ways people used to get poisoned by lead was from lead in paint. It also accumulates in the soil from just general contamination. It's not normally in the soil. It's also, although less than it used to be, it's in batteries, especially car batteries. It used to make up various bits of old car batteries. And so you occasionally see this in cows, for example. Somebody dumps an old car battery in a field, and after about 15 years, it just falls apart and the cows start chewing on it. And so that's why you can see lead poisoning in batteries. So I say, why do they use them in batteries? I think they would actually use them as one of the electrodes, but I can't remember which one. motor oil, there's lots of lead in used motor oil, or there used to be, and we'll come back to where this is in a bit. And then the other source of lead is obvious chunks of metal, which of course is what this little dog had eaten. So flashing lead pipe, which people don't use anymore, but you still find it in old buildings. And so lead poisoning, you can get it suddenly, like this little dog did, or you can get it sort of slowly over time, cumulatively. And so in humans, the main sources of lead poisoning are people who work with lead as part of their job. And that's why nobody makes lead paint anymore, or lead car batteries. Actually, to use those things was actually relatively safe. But if you worked in the factory that was making them, then you would have a pretty short life, to be honest. Although the thing about paint is you actually see lead poisoning much more commonly in children, because what happens is you get people who they think, oh, I want to buy a house, but I can't afford one where it's all done. So what people do a lot is they buy an old house and they do it up. And that means, of course, scraping all of the paint and wallpaper paste off the wall, and chucking it in the bin and throwing it away. But all of the dust from that, of course, just falls onto the floor and settles on the floor. And for adults, actually, that's not too dangerous. But of course, if you've got small children who are sort of grubbing around on the floor and crawling around, sticking their hands in their mouths and breathing in dust and climbing under beds and things like that, it's actually the children of people who are doing up old houses who are the most likely people in this country to become poisoned by lead. And so I mean, this is an interesting one, because this is actually quite a big thing in veterinary medicine now, is using lead as a sort of indicator of health in people. So you use animals as an indicator of health in people, but also as an indicator of health of the general environment. It's called the one medicine concept. So there's certain things when you're a vet, when you see them, like environmental toxicity or abuse as well of animals, you immediately start to be concerned about who else might be in that household, especially children, obviously. But what about lead roof tiles on churches? Several of those need to be replaced at some point. Are they still used? Yes, they still do use lead. The main reason they have to be, they actually last a very long time. The main reason they have to be replaced is often somebody comes along and nicks them. But anyway, okay, so that's where it comes from. Why does it happen? Well, in dogs, so that's what happens in people. In dogs, it's because they're stupid, basically, like this little dog was, this little dog who became aggressive. And also that it's particularly a problem in cattle and, well, I suppose sheep as well, because when lead gets into a particular part of their stomach called the reticulum, it's converted into a thing that somebody's already mentioned, lead acetate. Now, acetate is the old-fashioned name for ethanoate, which is, if you go on to A-level chemistry, you'll do a bit of organic chemistry, and acetate is the old name for ethanoate. It's basically what happens when you drop lead into vinegar, is you get this soluble form that can then be absorbed much more easily and do much more damage. The other animals that we vets see them in is actually ducks and swans, waterfowl, basically, because people used to, it's not legal anymore, people used to use lead weights when they went fishing, and then when they finished with the lead weights, they just throw them away, and of course they'd be sitting by the watercourse, and eventually, especially if they had a bit of fishing line on them, ducks and swans would just eat them by mistake. And this is a radiograph, it's a bit of a wonky radiograph actually, of a swan, and these little white pellets down here, down in the swan's gizzard, are little pellets of lead. It's becoming less common as time goes on, because people aren't allowed to use lead anymore, but it still does happen, which implies that not everybody is following the law. Somebody's asked how much lead would have a fatal effect on the human body. That's interesting. Well, it depends. If it's acute, it's a lot less. If it's cumulative, it can be a lot more. So it actually varies. Somebody said, can any other metals cause poisoning, and why is it lead? Well, we're going to come on to that. Okay, so what signs do you see? In fact, here's a little graph of how poisonous lead is. And you can see not only does it depend whether it's acute or over a period of time, but also it depends whether you're a child, whether you're an adult, and it also depends what sorts of signs you're thinking of as being toxic. So of course there's different types of toxicity at different concentrations, but the two big gut regions that it affects are the two main tissues in the body it affects are the gut, the intestines, and the nervous system. So the gut, this is actually much more in animals that you see this. So it can be anything really, anything to do with the gut: vomiting, diarrhea, constipation, which of course are the opposite of each other, not wanting to eat, scientific term for that is anorexia, and colic, which just means abdominal pain. So it's just generally pretty unpleasant. Although weirdly, this dog didn't have those signs very well. He wasn't eating, but apart from that, he didn't have anything more specific than that. He was really in the second lot: nervous signs, especially younger dogs, excitability, hysterical barking. Yeah, he had that. He didn't have fits or seizures. He hadn't gone blind, and he hadn't got paralysis. He was actually more aggression. So I think we sort of put that in with excitability. He wasn't paralyzed, and actually horses get a rather strange thing with their voice box, or their larynx gets paralyzed, and that causes difficulty breathing. So weirdly different in different animals. So he was the nervous type. He was not eating, but he was aggressive, and so that's why it was because of the lead he'd taken in. Just a little thing at the bottom: for some reason in lambs you get completely different signs. You get kidney toxicity and effects on the bones. Someone's just asked, does the lead leave the body at some point, or does it vary due to location? Well, how it leaves the body is going to become important in a second. Okay, so why does lead cause poisoning? Well, lead probably isn't supposed to be in the body. It's not thought to have any actual function in the body normally. We don't need lead for anything, we believe. Some people debate that, but we don't think we do. However, it looks to many of the processes in the body quite like certain other elements. So lead forms, now I've called them here divalent cations. It means that lead atom very often, like when it forms, say, lead acetate or lead chloride, if you had it in your stomach, the lead atom loses a couple of electrons and becomes Pb2+, becomes a divalent cation, Pb2+, a double positive charge. And there are other things that do this as well, which are very important for life, like calcium, iron, and zinc, that have lots and lots of different important functions all around the body, doing hundreds of different biological processes. And we think what happens is that lead is mistaken for one of those things, so it sort of gets incorporated into hemoglobin by mistake, or or nerve cells think it's calcium and actually it isn't, and it all goes horribly wrong. So we think the reason that lead causes these toxicities is because it's mimicking other elements that sort of look the same to, a cell. So it looks the same, it enters that pathway, but then it jams it all up and stops it working. There are other elements that can do this. The other one, somebody asked, are there any other elements which are poisonous? Another one is mercury, which you can see is only 2 along from lead, Hg. Yeah, a strange story behind why it's called Hg. Some of these ones up here do have rather strange names. So mercury is another one. Another one would be arsenic, for example, and they all look quite similar, all these different poisonings. So despite the fact they're completely different elements, they probably jam up the same general sorts of things. Mercury poisoning is less common than lead poisoning, just because very, very little mercury is used industrially anymore, and it's not used domestically, and people are generally pretty careful with mercury. The problem with mercury is, of course, it vaporizes into the air. So it's mimicking these other things. And so if you're already a bit deficient in some of these things, or just marginally deficient, which you can be perhaps for zinc, for example, it's probably less likely for calcium or iron, then that means that it's easier for lead to jump in. Okay. So lead has quite a history to it, so it's almost a bit of a history lesson today as well. Lead is actually, naturally, there isn't any metallic lead in the environment at all. There just isn't any. It's all bound up as various salts, and the most common of these is galena, or lead sulfide. And this is one of the reasons the Romans invaded Britain, is because they knew that there were lots of deposits of lead sulfide around the country. And this is a huge ingot, a 70 kilo, so about as heavy as a bloke, really, that was found in Matlock in Britain, excavated from near where there was a Roman villa. And so this is a 17 kilo ingot of lead that was smelted during the Roman era. Of course, you can just imagine all the vapor coming off. I mean, lead will vaporize if you heat it. It must have been pretty grim work preparing this. And so it has a long history in this country. And the thing that used to be a big problem with lead was that lead was put in petrol. And you may think that's completely stupid. But what it was is several decades ago, there was a problem with early petrol engines, which is that the lead would sometimes the petrol would sometimes get into the cylinder in the engine, and it would ignite in a sort of uncontrolled way, and you get a little bang. And it was called knocking, because the engine would sound like it was sort of rattling as it went along. And they tried various things to stop this happening, but for some reason the one they decided to use was what's called tetraethyl lead, and this is its structure on the left. The dark green thing in the middle is the lead molecule, and sticking off the side of it are 4 little ethyl groups. They're 2 carbons and 5 hydrogens in each. And this weird compound, you put it in petrol and it makes your engine run beautifully smoothly, which is all very well, except of course it means that your car spits lead out of the exhaust. And so there are huge amounts of lead being just shed, vaporized into the atmosphere until the 80s. I mean, I remember when leaded petrol was finally banned. It wasn't that long ago. And that's why all petrol that you buy at service station now says unleaded. And you may think, why do they call it that? Well, the answer is because it used to all have lead in. So that's rather a nightmarish story, and then we will return to lead in petrol. A couple of questions. Well, there's one I'm going to leave till the end. One is, didn't pencils used to be made of lead too? The answer is no, they didn't. Pencils were never made of lead. They were made of various things, clay or graphite, and I don't know why it was called lead. I've actually been to a museum quite near to where Catharine comes from, actually, in Keswick, which is the Pencil Museum, and they explain this at great length. I'm that kind of guy. I went to the Pencil Museum, and actually, I tell you, there's what they made a pencil from lead. And it's in the museum, and you can see it just doesn't really work at all. So yeah, I don't know why the pencil lead in where the lead in a pencil is called lead, because it's not. So anyway, that's a bit of Cumbrian folklore for you there. Right, okay. Now, as I said, lead, naturally, there is none of it in the environment. And this has led people to wonder, well, how exposed are we to lead in the modern world? And this is a graph from about 3,000 years ago to the present day of the worldwide production of lead metal, because as I said, there's no lead metal in the natural environment. It's all lead sulfide or some other compound. And this is quite an alarming graph. You think, well, it's going up fairly steadily, but the point is each of the horizontal lines is actually 10 times bigger than the line underneath it. So this dot up here, for example, is 10,000 times more lead than this dot down here. It's called a logarithmic or a geometric scale on a graph. And you can see that there was no lead in the environment to speak of until they discovered cupellation. This was a way of getting certain metals out of ores by heating them with various things. And then there was a big jump when the Greeks and the Romans, and probably the Chinese as well, started purifying metals to make coins and things like that. And then there's a big surge during the Roman era, lots of lead being spewed into the environment then. And then the Roman Empire collapsed, and then in the Middle Ages it dipped a bit, but then they started making metals. They burned charcoal with ores and things like that. This, it just went up and up and up and up to up here. So you can see it's gone up rather ferociously and rather frighteningly over the years. And this graph, actually, it was very difficult to create this graph, because there's a guy who's working in Los Angeles in the 1950s, and he wanted to study the history of lead and whether it was poisoning everybody. And he found that it took him 2 years just to build a lab that wasn't completely contaminated in lead, because of course there were cars driving along outside full, spewing out lead all the time. So it's very difficult to measure these pre-industrial levels, because we're all just swamped in lead all the time. And these are two much more recent graphs. They're kind of showing the same sort of thing, because if you look at, say, the blue line up here, this is the amount of lead spewed out in petrol between, what's this, 1964 and 2010. And you can see there's a peak around the early 90s, and then it declines because no more cars were made that took leaded petrol. So it's gradual. So this is the level of lead being spewed out into the environment. This black line down here, so this is in America, and this is the blood levels in people in Britain. And you can see that they were quite, it's actually preschool children. Yeah, great. And you can see that these kids, well, actually, yeah, kind of when I was a preschool child, really, we were full of lead. And these are levels of lead which are marginal for causing long-term toxicity. But you can see it's come down a lot recently. So you guys haven't been exposed to this nearly as much. And you remember I said that lead causes little dog to be aggressive. And one thing that people have noticed is that if you look around the world over the last sort of 30 years or so, there's been a decline in violent crime in everywhere, regardless of that country's politics, or whether it's an oppressive regime or whether it's very liberal. The level of violent crime has pretty much followed the curve of this red one. This is the US up here. And these red and blue are the crime index in Britain. And people have wondered, is this because people are getting pumped less full of lead? Because lead is known to cause aggression, and it certainly was, when I was a kid, getting up to toxic levels in everybody's blood, pretty much. And the answer is we don't know. I mean, this is a good example. There's a very strong correlation between levels of lead and violent crime. That doesn't mean that lead causes violent crime, but it's pretty suspicious anyway. And it's a good news story. I mean, that's one of the ways you look. There are a lot fewer policemen in this country than there used to be. And this is one reason why we've kind of got away with having fewer policemen, because there's less violent crime going on. There are other sorts of crime instead, but there's less violent crime. So just to answer a few questions quickly, was lead ever used for malicious purposes like war? Not as far as I'm aware. Well, apart from making bullets, obviously. Not as far as I'm aware. Doesn't mean it's not. I've never heard of it though. Can lead still be dangerous as salt? In a way, it's more dangerous as a salt, because salts are often soluble. You often can't absorb it until it's become a salt. Also, how does lead make people aggressive? Well, because we think it's because it mimics calcium and affects nerve cells. That doesn't prove causation. We haven't proved causation for any of this. Okay, global lockdown reduced lead poisoning crime. Well, there was less crime because less people were out. Long-term lead toxicity in the environment would have gone down, probably wouldn't have been affected by, you know, a year's worth of reduced lead production. I wouldn't have thought. I don't know, but I wouldn't have thought so. So that brings us back to our little dog. So what do we do for this poor little dog? Because he's had lead. And where was all this lead? Well, I looked it up, and the lead doesn't actually sit in the blood very much. Of course, the lead that's making him feel horrible is in his blood. But the lead, most of the lead in his body is actually somewhere else. It's in his bone, because I said it can mimic calcium. And that's what happens is the lead, if you eat lead, most of it then deposits in your bones. So this dog was sort of self-poisoning. He was leaching lead out of his own bones, and that's what was making him feel horrible and ill and aggressive. So I looked at it and I thought, well, what do you do then if he's got all this lead in his? You can't take his bones out. So what you do is you use some very complex compounds. They're called chelating agents. One is called EDTA, which is this one over here on the left, which is quite complex. But you can see it's quite a symmetrical molecule. And this is its structure up here. And what these things do, this is the one they use nowadays. This is slightly less toxic, but basically we'll use the old-fashioned one because this is what I used on the dog. Is this stuff likes these metals. So if you put it in with calcium or lead or zinc, it forms a little cage about them, and that's what it's doing in this upper right picture. M is metal, and this is this molecule kind of grasping it like a little claw, like a little hand, and hiding it away. And what you do with these dogs is you take this stuff on the left, bound to calcium, and you put it in a drip bag and you inject it into the dog, and this goes into the dog's circulation, and lead displaces the calcium from this, and so you end up with this bound to lead and calcium, which is harmless, and then the dog's kidneys can take this stuff and put it in the urine and get rid of it, and it comes out the back end of the dog. And so I did this. I thought, I don't think this is going to work, but we got a bottle of EDTA, and we stuck it into a drip bag, and we dripped it into this dog, and within about 3 hours he was lovely again. He was all friendly and he was feeling happy and he was hungry and everything was fine. And I sent him home, and he came back 3 days later and he was ill again. So I just stuck him on another drip bag, and he went away he was fine again. He went away for another 4 days, came back in, ill again, stuck him on another drip bag, went away for another, I don't know, 6 days, and the intervals gradually became longer and longer. And the reason for this is that he was gradually leaked. I was extracting it from his blood, and then his bones were refilling his blood with lead. And then I'd have to get rid of that, and then his bones would but gradually the amount in his bones was going down. So you get, when you learn to be a vet or a doctor, you do some fairly horrific maths. This is why vets and medics have to be good at maths and do lots of maths at school, is that this is the formula for the curve that you get. So I took all of his lead out, and then it gradually came back in from his blood, and that's the shape of this curve. That's the equation for this curvy curve here. I then took all the lead out of his blood, and then it came back, but it took a bit longer because there was less blood in it, less lead in his bones. And then it took a bit longer, then it took a bit longer, then it took a bit longer, and then eventually he was fine, and he just got it out of his blood on his own. Eventually, last time I think he was away for about 2 months before we gave him his last drip of calcium EDTA, just to get that lead into soluble form that his kidneys could excrete. And yeah, then he was better, and he was a lovely little dog again. The reason I choose this is because obviously there's some chemistry in there. There's a bit of physics, because we're thinking about sort of the periodic table is basically physics, I guess. And also, as you can see, there's some maths in here as well. And this is to show you that really, when you really start digging into biology, you find actually it's just maths, physics and chemistry, but a bit squishy, really. Yeah, that's how it works, and that's why I sort of like to use this, because it sort of shows you something. Why do I have to do all this chemistry and maths and physics and stuff at school? And the answer is because you actually, if you become, for example, a clinician, or you become an engineer, or you do all sorts of things, you actually do use this stuff every day of your working life. And that's one of the great things about science, is all the basics you use again and again. And this is why, so for example, if you applied to Cambridge to study really any science, that if you were interested in any science and you'd read about anything about any science, that would be good, and we would be interested in that. It's what we like to call supercurricular studies, reading extra bits about things you're interested in. But that's why any science will do. If you're applying to be a vet and you're interested in physics, that's great. If you're applying for physics and you're interested in medicine, then that's great. It's all science and it's all good. Okay, couple of other questions. One was, that must be a horrific process though. Actually, we just left a cannula in his leg and he went home with a little plug in it, and then we'd have him back in and just connect him up again. He only had to be in for a few hours. So actually, no, he was all right. It wasn't too bad for him, really. I think he got used to it. He quite liked us by the end of it. And somebody else said, what elements are in jellyfish stings or other toxic bite poison? Now, I've been talking about probably the simplest chemical poisons of all, which is where it's just a single element like arsenic or mercury or lead. Most poisons are much more chemically complicated, and the ones that are made by animals or plants, like jellyfish stings or the things you find in the leaves of yew trees, they can be tremendously complicated compounds. So they often cause much more specific effects than metals. So they may only actually act on one molecule in the whole body to cause their toxicity.
Thanks, David. We've got a couple more questions from the chat as well, but
Okay.
if anyone else has got any questions, we've got some time now until 7 for you to ask David anything you'd like about this talk or about his work in veterinary medicine. But the next question we've got, someone's asked, obviously you mentioned earlier about how lead mimics these other elements in the body, but you didn't see, it wasn't clear whether it was we were too sure on how they actually work and how that process is once lead's in the body. Is there stuff that we don't know about how lead works when it's in the body, when it's poisoning people or animals?
There are things we don't know, although lots of the signs that you see with lead they make sense if you think it is mimicking things like calcium. So for example, we know exactly how calcium interacts with lots of proteins, and proteins are often either enzymes or they're things which are allowing things to run to, or things like, or they're proteins which are allowing things like calcium to go across cell membranes in nerves. And we know a lot about that process. And so we know a lot about the process that we think lead is sort of edging its way into, even though we haven't necessarily always studied what lead in itself is doing. So in general, the signs that you see with the heavy metals do make sense. So, and the processes are pretty well characterized. So iron, for example, we know what iron does in mitochondria, and we know what iron does in hemoglobin, things like that.
Thanks. Someone's asked, random question, but at the beginning you mentioned the first time you performed surgery on a fish. How do you perform surgery on aquatic animals?
Well, if it's an animal that breathes oxygen from water, then it's actually quite easy. You basically drop the anaesthetic in the water they're swimming around in. You let them float up to the surface. You then scoop them out in a plastic bag, cut the corner off the plastic bag to let the water out. And as long as they're not back in water, the anaesthetic just stays in their body, so they stay asleep. And then you cut a little hole in the plastic bag because you don't want to touch their skin too much. They're very sensitive skin. You do whatever, and this was to take off a tumour off the side of a koi carp. You stitch it all up, then you drop them back in fresh water, and the anaesthetic just diffuses out into the fresh water, and then they wake up again. So actually, in some ways, it's actually easier than anaesthetising an animal that breathes air.
That's so cool. Thanks, David.
Why is lead used at all if it's unsafe? Because it's really useful for lots of things, unfortunately, like lots of poisonous things are. Bit of off topic. Do you need any extra training to specialise as a wildlife exotic vet? In this country, all vets just train to be a general vet. And then if you want to specialise, you tend to do that after you're qualified. It's not 100% distinction, but pretty much all vets in this country, you train to be kind of adequate at all the basic species. What are the most common poisons somebody would see as a vet? In this country, I would say antifreeze. Cats often drink antifreeze, which is quite horrible. Dogs, onions, raisins. The commonest of all, I would have thought, in this country is probably chocolate. It's very toxic to dogs, probably toxic to cats as well. They just don't eat enough of it. Don't use dog flea treatment on cats. That's another one we see very commonly, which can be quite horrible. Those sorts of things are really something. Oh, very interesting question. Is there any chance you could be born with lead poisoning? Yes, we believe it can cross the placenta. I should know this actually because I used to work on the placenta, but actually I don't. But we think it can cross the placenta and get into the fetus. So the answer is yes, you could actually be born with it as well if your mother is exposed to it. Someone said, to get into med school, do you need physics A level or biology, or is biology enough? I would advise you, you need to be doing 2 science maths subjects at A level. I would encourage you to do 3 because I think it's a better preparation, and certainly for some medical schools they might actually prefer you to have 3 or ask for 3. Exactly which ones they are, you may find that the one that you probably have to do is chemistry, and certainly that's true for Cambridge. Other than that, we don't really mind whether you do physics, maths or biology. If you haven't chosen enough sciences now, can you do more A levels in the future? So if you're at the GCSE stage, I mean, so for example, if you're doing, say, double science GCSE, that's fine. You don't have to be doing them all as separate subjects at GCSE. You don't have to be doing maths, physics, chemistry and biology. You can be doing maths and double science. So yeah, that's fine. I mean, because that's normally more just a question of, you know, what your school has got you to do, really what your school normally does. So GCSE double science is fine. You don't have to do the separate subjects.
We've also got a question that someone's asked in the chat. How does poisoning from metals compare to the effects of things like hallucinogens and depressants on the whole body?
I mean, those tend to have much more specific effects. So they really are acting, well, hallucinogens really only act on the brain, pretty much. Depressants, yeah, I suppose they act a little bit everywhere else, but they tend to have slightly more specific effects. I mean, so I mean, you've got a bit of a gradation. You've got you've got things like lead that have very, very generalized effects. You've got things like, say, barbiturates, depressants, which have quite widespread effects in the brain. And then you have things like hallucinogens, which really just act on 1 or 2 specific protein molecules in the brain. So it's a sort of question of specificity, really. So it says, what are the requirements to get into Cambridge if your school is an IB school? The typical offer is a total of between 40 and 42 with 776, usually in your higher 3 subjects. If you want to get into a good university for physical/life sciences, it's worth doing maths A level if it's not your strongest subject out of sciences and maths. I would look on individual university websites because it really depends what you want to do. There are some, like if you wanted to do physics, I would strongly advise, yes, you should do maths at A level, even if it's not your strongest subject. However, there are other sciences that you might want to do at university where the requirement for maths isn't so absolute. So it's never too early to start looking at university websites to see what sorts of things they want. And actually, one of the things that we spend quite a lot of our time trying to do is getting people actually, before they've done their GCSEs, to think about what they might need to go on to their chosen university course afterwards. Good question. Why is chocolate toxic to dogs, cats, and not to humans? First of all, well, chocolate's got caffeine. It's actually the things which humans really like. Caffeine is a thing that people really like, and just dogs and cats just seem to be very sensitive to caffeine. Their hearts are very sensitive to it. The other thing about it is it contains theobromine, which is actually the thing which is sort of vaguely addictive or habit forming in chocolate. Is just full on toxic to dogs' brains and cats' brains. And we don't really know why the difference is. I mean, you've got to suspect that it's because these animals basically largely eat very simple diets, whereas humans, over the course of their evolution, they've eaten a wide variety of plants. So they're very good at inactivating toxins in plants. And indeed, humans actually seek out plants with toxins in if the toxins taste interesting. So I think it's probably just the fact dogs and cats, because they have a more restricted diet, they have a much more limited metabolism, that they're not so good at getting rid of, well, things that would to them are poisons. So these things just build up in their system a little bit. What kind of things can one do to gain inspiration for sciences, STEM-based courses? Well, I would say anything in science/maths that you're interested in, just go and read about it or watch videos about it, watch YouTube things of people blowing things up. One of my personal favorites is Red Hot Nickel Ball, where they every week they heat a ball of nickel until it's red hot, and then they drop it on things like ice and watermelons and petrol and see what happens. So really, the internet is wonderful for things like this. You just, if you're interested in something, you just find you'll disappear down a rabbit hole of all the things that you could learn about.
Someone's asked a great question. Did you know you wanted to go into veterinary medicine when you were in kind of, year 10, 11, 12?
I knew I wanted to be in something sciencey. And actually, even when I was on the course, I didn't think I necessarily was going to be a vet in practice full time. Lots of these degrees, they're just a really useful qualification for lots of things. I actually did want to end up working at a university doing this sort of thing, actually, and being a vet was quite a good way into doing that. And like, for example, I'm now on the list. I'm a COVID vaccinator. Because I vaccinated animals, I could do the course, and I've trained as a COVID vaccinator. So it's even if you're not absolutely sure that these things are exactly what you want to do, still think about doing the courses, because they're lots of people who do physics don't work in physics. They go off and do lots of other really cool things. So it's more a question of just going onto a course that you think is a good course and that is suited to you and that you'll do best at, I would say.
Someone's asked, what does the daily life of a vet entail, David?
It depends what you do. I mean, about 60% of vets are in practice, and so you'll probably your 9 to 6 day will probably be a mixture of consults, seeing owners with their animals. Of course, they could be farmers, they could be pet owners, they could be horse owners, they could be zoos. And then so that would probably be about 2/3 of your day, and then another third of your day would probably be doing surgery, because vets obviously they tend to do both. They tend to do the sort of medicine side and the surgery side. So I used to start work at 9 o'clock. We were quite lazy, and I'd sort of do consults till about 11 or 11:30, and then I'd operate till about 2, and then I'd have a bit of a gap, and then I'd do some more consults from, like, I don't know, 4 till 6 or 5 till 7, and then you might be on call depending on where you're working. So yeah, but the great thing is you never know what's going to come through the door next, and you see boring stuff like my dog's got fleas, but then you see some really cool stuff, and unlike a doctor, you don't just have to then refer it off to a hospital. If I was a GP and I saw somebody with lead poisoning, I'd have to refer them off somewhere else, whereas because I was a vet, I could take this case all the way from the beginning right through to the end and do it all myself. So that was fun.
Thanks, David. Someone's asked, what's the best veterinary school? I mean, you might be a bit biased being at Cambridge, but what would you say?
The good thing about being in Britain is that, well, there's a new one that I don't know anything about because it's only really just started, Harper Keel. But you're lucky because they're all good. And that makes life easy. They're all slightly different, and we all sort of talk about this, and so we do encourage you, if you're thinking of applying to vet, we actually produce a document. It's called the vet. If you just Google Vet Schools Council applications, and admission or something like that, there's a PDF file where each vet school, I edit this every year, produces 3 pages about what's different about that, why you might want to do the course with them and why you might not want to do the course with them, because obviously we want you all to go to the place where you're going to sort of enjoy it the most. So I would try and hunt that out. Vet Schools Council application admissions, just Google that and you'll get this document. Obviously I would say Cambridge is the best, and in that document we explain why we think Cambridge might be the best vet school for you, but it may not be the best vet school for everybody. Yeah, that's what I would say.
Thanks, David. I think I'll just ask one last question, which is, what's a kind of key quality that you think you should have if you want to go into veterinary science, or a key skill?
They're really, yeah, it's hard to divide them really. I mean, it's an interesting thing because it's a mix. You want to be good at science, but you want to work with people as well, because you're going to be talking to people all day long, and so it really, you can't separate the two and say which one is more important, because you're going to have to be able to do both. You can't do, well, it's very unlikely that you'll be able to just work with the animals. They usually come with a person attached.
Thank you, David. I think that's all we've got time for today. I know we've got a few questions, but if we didn't get around to answering yours today, then please do email me. My email address is in the chat. Thanks so much to David for coming along this evening to this talk. Thank you guys for coming along and listening to us and staying until the end. When I end this webinar, a little post-event survey will pop up. It'll only take about a minute. If you could quickly fill in that little Google form to let us know what you thought of today's session, that would be really useful to us. Thanks so much for coming. You've been so engaging and enthusiastic and had better answers to the questions than I would have done. If you're interested in any of the other academic taster sessions that me and Joe are running over the coming weeks, then please do sign up and come along and get to know some of the other subjects as well. Thanks so much, David. Thanks, everyone. Have a nice evening.
Bye.
Bye.